In this video, we're going to build on Alfred Wegener's theories of continental drift into a more complete theory of plate tectonics. We're going to look at Harry Hess, the mid-ocean ridge, the age of rock strata, seafloor spreading, magnetic striping, and finally plate tectonics as a theory. So Harry Hess was an American geologist. He studied at Princeton University, and when World War II started, he joined the army and was put in charge of a boat called the USS Cape Johnson. Now, a technology that was fairly new at the time was sonar. And what happened with his boat is it was fitted with sonar, so it could send out a very high-pitched sound that you can't hear with your ears, but it would echo through the water and bounce off anything. And the reason that the boats had this is so if they were going through or coming into a harbour, or there was a tricky part where they didn't want to crash or they needed to know the depth of the water, they could turn on the sonar while they were doing that and then turn it off again. But Harry Hess, because he was interested in geology, he decided that he'd leave his sonar on the whole time, and got a whole heap of different recordings and recorded the features of the sea floor. And he found that there were mountain ranges as well as channels all the way through the ocean floor. And this wasn't expected at the time. Everyone expected that the ocean floor was flat, but he showed that it wasn't. One of the things that he discovered is that there is a mountain range running through the center of the Atlantic Ocean. And he called this mountain range the mid-ocean ridge, because it was basically halfway between the two continents in the center of the ocean, this big mountain range. And there was also, he noticed, a crack down the center of the mountain range, which was a bit odd. Another thing that was found, and this happened after the war, but what they did is they drilled core samples of different parts of the ocean floor. So they got the rock from the ocean floor and brought it up to the surface and studied it. And what they found was that the rocks near the mid-ocean ridge in the center were very, very young compared to the rocks further away. So the rocks near the continents were much older, up to around 200 million years old, but there wasn't any rocks older than 200 million years, which again was strange because the continents were much older than that. So Hess explained this with the idea of seafloor spreading. So he proposed the theory that at this mid-ocean ridge, what's happening is the seafloor is spreading, so spreading apart at the ridge, and the magma from the center of the Earth is coming up to fill the hole that is left by the two parts of the sea spreading, and it cools and forms a brand new piece of seafloor. So that's why at the mid-ocean ridge the rocks are young, and at the edge of the continental margins the rocks are much older. And in further to that, he said that the seafloor must be going underneath the continents and back into the magma and therefore being recycled, which is why there wasn't any older rocks than sort of 200 million years. So he, talked about the seafloor spreading and recycling of the seafloor. Another thing, and this happened after he proposed his theory, sort of late 60s, early 70s, it was shown that the magnetic field of the Earth, so where a magnet points, like a compass, will point to the magnetic north, the north point of a compass, that actually changes about every 200,000 years. And it reverses. So if in 200,000 years' time, if you've got a compass rather, the north point would actually point to the south because the magnetic north pole would be at the geographic south pole. This happens at every 200,000 years or so. So what they can actually do is by looking at the iron in the rocks, they can work out which way the magnetic field was when that particular rock cooled from the magma. And what they found is that there's what's called magnetic striping. So in one section, all the rocks would be pointing north. Then in the next section, they'd all be pointing south because of the reversal. And then in the next section, they'd be pointing north again. So over time, they show that each of those stripes is taking 200,000 years to form, all facing in the same direction. Then changes, another 200,000 years of the rocks forming facing the other way, and leaving it with stripes. This seafloor spreading, as well as the continental drift, has all gone into what we now call plate tectonics, the theory of plate tectonics. And that is that the Earth is divided into 8 to 12 large plates and 20 or so smaller plates. And these plates are all moving in different directions. Some of them have land masses on them, and we call those ones continental plates. And some of them are purely oceanic plates, so they only have seafloor with ocean above them. In this video, we've looked at Harry Hess and his work in the Navy, mapping the seafloor using sonar. We've looked at the mid-ocean ridge that he found in the Atlantic Ocean, the age of the rock strata being that they're young near the mid-ocean ridge and older further away, the seafloor spreading as to Harry Hess's theory that explains why they're younger in the center and older at the edges, and another piece of evidence to support Hess's theory, which is the magnetic striping with the pole reversing every 200,000 years. And we've rolled all this into the theory of plate tectonics. So there's plates, both continental plates and oceanic plates, that are floating around on the Earth, moving in different directions.